We have already learned that a body is said to be in motion if it changes its position with respect to a reference point. Now, having learned what is motion, let us study the simplest kind of motion, which is motion along a straight line. So this rocket, it goes vertically upwards. So this is moving along a straight line. This is an apple falling down from a tree. It moves vertically downwards in a straight line. So this is an example of one-dimensional motion. This train moving on a straight line track. It is also moving along a straight line. The drawer of a table. Now you can either pull it or push it. You cannot move it to the left or right or up or down. So it just moves along a straight line. So this is also an example of motion along a straight line. Motion along a straight line is called one-dimensional or rectilinear motion. So it is one-dimensional or rectilinear motion. It can be to and fro. That is to and fro, like it happened in the case of the drawer. But it has to be along a straight line. So answer this question. Which of the following are examples of rectilinear motion? Now let us look at these examples one by one. The motion of a cricket ball when a batsman hits it for a six. So this is the movement of a cricket ball and the path followed by a cricket ball when the batsman hits it for a six. And we can clearly see that it is not a straight line. So this is not an example of rectilinear motion or one-dimensional motion. A ball thrown vertically upwards. This is a ball being thrown vertically upwards. It goes up and comes down. So although it changes its direction, that is upward direction, downward direction, but it moves along this straight line. So this is an example of one-dimensional motion or rectilinear motion. Third is bullet fired from a gun. So this is a bullet being fired from a gun and it goes at a very high speed, but it goes along a straight line. As we can see here, it goes along a straight line. So this is an example of rectilinear motion or one-dimensional motion. And the last is athletes running on an oval track. What do you think? What will be the answer? So this is an athlete running on an oval track, and we can clearly see that it will follow an oval path and not a straight line path. So this is also not an example of one-dimensional or rectilinear motion. So having learned what is one-dimensional or rectilinear motion, let us see how we can represent one-dimensional motion. So let's take any of these examples, say a ball thrown vertically upwards, and see how we can represent it. So this is a ball being thrown vertically upwards, and we note its position at different points in time. So at t equal to 0 seconds, the ball was at 0 meters. So we mark a point at 0 meter. At t equal to 1 second, the ball was at 10 meters. So we mark a point here. At t equal to 2 seconds, the ball was at 30 meters. At t equal to 3 seconds, the ball was at 40 meters. Then it started coming downwards. At t equal to 5 seconds, it was at 20 meters. And at t equal to 6 seconds, it came at 0 meters. That is from where it was thrown. So we take an axis and mark the points on this axis. However, representing motion in terms of vertical axis is not very convenient. So what do? We take this axis and we tilt it. So we represent one-dimensional motion on a horizontal axis. This axis is nothing but a ruler, as we can see. So a ruler marking the point 0 meters, 10 meters, 20 meters, 30 meters, and we mark points corresponding to each time. So we represent one-dimensional motion on a horizontal axis. This is irrespective of the direction in which the motion is taking place. So as in our example, although the ball was being thrown vertically upwards, but for that also we represent it on a horizontal axis. And after representing it on this axis, we record the motion on a table. So we represent time. Time is noted in seconds here. And we represent x, which is the position vector. So this is the position vector in meters. So let's fill up this table. At 0 seconds, where is the ball? The ball is at 0 meters. At 1 second, the ball is at 10 meters. Then next is 2 seconds. The ball is at 30 meters. 3 seconds. The ball is at 40 meters. At 5 seconds, the ball is at 20 meters. And at 6 seconds, the ball is again at 0 meters. So this is how we represent it in a table. So we have learned that motion along a straight line is one-dimensional or rectilinear motion. We can represent it on a horizontal axis and we record it in a table.